So for this video, we are going to translate these expressions into an expression of sine, and then translate them into an expression of cosines. Now what's kind of nice about this is the order doesn't necessarily matter, but I will show you that the first technique you should try to do is to try to use either the quotient property or the reciprocal property and see what it becomes when you first of all try it. Now you might see this in the homework as like secant theta or semicolon sine theta, so it wants you to take the secant theta and turn it into an expression of sine. And again, there's just different ways of writing a problem like this, and this is the way that I'm going to express it. So I want you to take the secant and tell me what that is as an expression of sine, and also then as an expression of cosine. So the first thing that we're going to do is we're going to just see, what is this equivalent to? Okay, so what this is equivalent to is 1 over cosine theta. Okay, 1 over cosine theta, we now have our cosine expression check, so this is one of our two answers here. Now what I'd like to do is I'd like to write this as an expression as a sine. Now, one of the keys to doing this homework section is to remember that the sine squared theta plus cosine squared theta is equal to 1. So if I have to convert this expression into an expression of sine, I can actually just isolate cosine here. I can just subtract the sine squared theta from both sides. Okay? And this is a legal operation since this is an equation. These simplify to 0, and then now what I have is cosine squared theta is equal to 1 minus sine squared theta. Then I'm going to take the square root of both sides, and now what I have here is cosine theta is equal to plus or minus 1 minus sine squared theta, all under the radical. And this can't be further simplified. I cannot take the square root of this binomial. So cosine squared theta is equal to plus or minus the square root of 1 minus sine squared theta. So now for my expression of sine, I am now going to turn this expression into 1 over plus or minus the square root of 1 minus sine, sorry, that's written a little sloppy there. Let me clean that up a bit. Okay. Plus or minus the square root of 1 minus sine squared theta. Now the plus or minus can move up in front of the fraction because we're taking the positive and the negative value of this. So one way to write this is without any positives or negatives, and the other way is to write with a negative. So you can put the plus or minus stylistically in the front, as your XYZ homework will have you do, as a little toggle switch. And this is your answer for this expression in terms of sine. And so that's what we're going to do. We're just going to see how it looks as an expression of sine and an expression of cosine. So tangent is going to be written as, thanks to the quotient identity, this is going to be sine theta over cosine theta. All right, now we're not actually done writing this as an expression of cosine or as an expression of sine, but I can take this numerator, since I can kind of like isolate this, sine squared theta plus cosine squared theta equals 1. I can solve for sine if I'd like to, and I will. I'll subtract the cosine squared theta from both sides. Now, those of you thinking ahead a little bit might see some symmetry in what I'm doing in red to what I did up above in black. Okay, so now my sine squared theta is equal to 1 minus cosine squared theta. Take the square root of both sides. Now my sine theta is equal to plus or minus the square root of 1 minus cosine squared theta. Now I'm going to highlight this in yellow, okay? I'm going to highlight this in green. These are two very powerful formulas here. And they're formula because it allows us to take this expression, this sine theta over cosine theta, and now I can write this as, in this direction here, I can write it as everything in terms of sine, where my numerator is now sine theta, and my denominator is now, since cosine theta is equal to plus or minus the square root of 1 minus sine squared theta. So now I've done my sine expression writing. So tangent is literally sine theta divided by plus or minus 1 minus sine squared theta. Now I can also rewrite this sine theta over cosine theta with the green part here, where I can say that my sine theta is equal to plus or minus the square root of 1 minus cosine squared theta divided by cosine theta. Both of these expressions, this one here written as an expression of sine, and this here as an expression of cosine, this is tangent. And these are my two equivalent ways of writing it, which is pretty awesome, right? So I'm going to circle this as my answer for sine, and circle this as my answer for cosines. Now, what this is doing is it's building up your mathematical muscle to get you to convert from one thing to another. Now keep these handy, because to do the next problem on the next page of your packet, you're going to then need those maybe for the end conversion here. So what we have is this expression, and again it's just filled with non-sine or cosine. So let's actually convert this into sine and cosine. So let's do our secant as 1 over cosine theta, and let's do our cosecant as 1 over sine of theta. All right, and our denominator here is 1 plus tangent, which is sine theta over cosine theta. And here we have, from college algebra, a complex fraction. So now that we have a complex fraction, what we're going to need to do is we're going to need to combine our denominators here. So I'm going to highlight this in yellow and say I'm going to get a common denominator between the cosine and the sine. So I'm going to multiply this by sine over sine. Okay? I'm going to multiply this by cosine over cosine. Okay? Sine over sine and cosine over cosine. So what this means is this sine times 1 is now just sine, and this cosine times 1 is now just cosine. So I got sine theta plus cosine theta all over cosine theta sine theta. So that is my denominator, or my numerator, in yellow. Now I'm going to work on my denominator. My denominator has a denominator of cosine. Okay, so I'm going to highlight this in green so we don't lose track of it. So now what I need to do is just multiply this first this 1 by cosine over cosine theta. And so now what I have is cosine theta plus sine theta, all divided by now cosine theta. So this numerator in yellow, this denominator in green, I'm going to skip, flip, and multiply. So that means my numerator here in yellow is going to be written as sine theta plus cosine theta divided by cosine theta times sine theta. We're going to multiply that by, what's this in green here? And that is going to be now flipped, because we skip and flip and multiply what's in green. Cosine theta divided by cosine theta plus sine theta. Did you see my voice kind of change a little bit? Because I'm noticing that this is cosine theta plus sine theta, and this is sine theta plus cosine theta. Thanks to the commutative property, I can switch that around in my head and go and cancel these two. All right, wow, look how easy this is getting, because now my numerator is cosine theta, and my denominator is cosine theta sine theta. So these simplify, which gives me 1 over sine theta, And lo and behold, ladies and gentlemen, we have now just done this equation rewritten as an expression of sine. We're done with half of our work here, even though we did 90% of the work, because now to convert this into an expression of cosine, this is just going to be 1 over plus or minus the square root of 1 minus cosine squared theta, because we can use that from the previous. And there, my friends, we have 1 over, I'm sorry, not 1 over, we've done our cosine expression simplification. So this expression, secant theta plus cosecant theta divided by 1 plus tangent theta, is the same as this and this, written as either an expression of sine or as an expression of cosine. Great work, great work. We are now going to head on to our final video, where we now don't need to narrow this down to just sine and sine or cosine. We can now combine them into sine and cosine.